one thing that we noticed when going from 2D oriented applications to 3D is that working with 3D data is sometimes less intuitive than working with 2D data. Your camera in 2D is constrained. You're looking from the top essentially on your data. So you have navigation in 2 degrees of freedom, but in 3D there's a lot more factors. You can not just navigate in 3D, but you can rotate and tilt your camera in various ways. And if you don't manage that in your application, if you don't restrain in a certain way what the user can do, then they'll get lost in the data.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Joris Scholteden. Joris is the Director of Research and Development at Luciat, which is a part of Hexagon. And today on the podcast, we're going to be talking about geospatial applications in a web browser. So we're going to be talking about streaming data, what we need to do to make our data streamable, what is streamable data, and what can we do with that data once it arrives in the web client. Hi Joris, welcome to the podcast. Today we're going to be talking about geospatial data in the web browser. And I think before we dive into that topic, perhaps you could just take the time to introduce yourself to the audience, maybe explain how you got involved in geospatial and perhaps where you are today.
Hi, Daniel. Thanks for having me. So yeah, I'm Joris Schouteren. I'm the Director of R&D at Luciat, which is part of Hexagon since about 3.5 years. We're making software components for development of geospatial applications, including on the web. I've got involved at Luciat because it's foremost it's a local company. I'm living in Leuven, and the company is the headquarters, at least, is based in Leuven, in Belgium. And I started out as a software engineer and technical lead for many years. So I have lots of technical knowledge about GIS and everything around that. And I've been deeply involved in our web development and 3D visualization SDK, and also 3D processing on the back end.
I really want to talk about this web, like geospatial in the web browser, and why it's important and what we need to do to make this happen. Could you maybe sort of briefly describe some of the advantages we get when we display and interact with data through a web browser?
So first of all, you get all of the well-known advantages of web apps in general. So it runs everywhere, even if need be on a mobile device. You don't need to install software or ask IT to keep it up to date or get licenses, etc. And it's secure since your data is on the backend and centrally managed. It's scalable as well because you can offload certain tasks to your backend infrastructure and keep the interactions to the web client. For geospatial specifically, I think it's important because it shortens workflow times. You don't need to send large data sets around, possibly on a DVD, which still happens, and have long loading times to get it on your screen. You can easily share your data across people, not just data, but actually also functionality, because you can share dedicated applications or make views on your application or functionality for different targets audiences easily, power users versus people that are using a specific task. It also allows you to combine data services from various places, which you can do also on a desktop app, but it works really well in a web app to get data from different vendors, different services, government or otherwise, or your own, into one application.
So when I think about applications that run in a web browser, I immediately start thinking about streamable data. And I think perhaps we should start there. Would you mind describing for us what is streamable data? And especially what is streamable data when we think about geospatial data?
I think you've touched the cornerstone of a good web application, and especially a good geospatial web application, because the data in this geospatial world is typically very, very large, or can be very large. Just to give you an example, it's not uncommon to have an aerial image of 100,000 by 100,000 pixels, or an unstructured point clouds that is terabytes big. You just can't load it in a web browser. It would take too long. It would overload your PC, etc. So you need to stream it in some way, and streaming means loading the data incrementally. So only the parts that are necessary or predicted to be necessary in the near future, so that you can keep your view on the data small. And that has many advantages. One advantage is that you get to see the part of your data that you're interested in fast, instantly, if possible, and it doesn't overload your system. So that's to compare with, for example, a well-known streamable data that is a video stream on video on demand website, for example. a very linear stream and linear in time in this case. You can jump to a certain time and you will see your, for example, in YouTube, you will see the gray bar loading up when it caches ahead so that you have at least a buffer ahead of you. But you don't need to download the whole video to be able to jump to the middle and see parts of that. So that's I think a good comparison. In geospatial, the data is a lot less linear. There's still some coherence because you navigate in 2D or in 3D or sometimes in 4D if you have time information in your data set. So there's still locality, as we call it, in the data. If you're looking at a certain area, you're very likely to look at parts around that area, go left, go right, zoom out, zoom in, etc. So you can use that information to load data that is applicable to what you're looking at and maybe cache ahead a little bit or things like that. The way that is typically done for geospatial data is to tile and multi-level your data. There are other ways, for example, wavelet compression, where you can get less detailed information first and display that while you get additional wavelet information to refine your display. But the most common way is to use tiling and multi-leveling. Tiling is chopping up your data in spatial chunks, so in physical areas. These spatial chunks can be either 2D or 3D. It's typically 2D if you're talking about large-scale data, for example, aerial imagery, an aerial LiDAR data set, or a vector data set containing street data and things like that. So there, you typically chop it up in 2D blocks. Whereas if you're talking about terrestrial scans, for example, you scanned the interior of a building, or you have a BIM model that represents a building, there you can typically chop it up in 3D blocks rather than just horizontally in 2D. So that tiling allows you to load the tiles that are relevant, but it goes hand in hand with multi-leveling. Multi-leveling is having less detailed versions of your data available. To give you an example, if you zoom out in a web app, at some point you'll want to see all of the data because you're zoomed out so far that you see in the entire world, let's say. If you would then have to load all of the tiles, that would still be an enormous amount of data. So what we do is we create tiles at less detail so that we can load these. And that's fine because you're looking from far away, so you don't need the full detail. You can't even see it because it's smaller than a pixel, let's say, and it loads very fast. It's easy to imagine, I think, for a raster image, you can easily create a subsampled image. That's something that you can imagine. But the same technique applies for LiDAR data, mesh data, as well as vector data. And I guess that's commonly called LOD, level of detail, these two things combined. And the ultimate goal is to have a low latency to get your data on screen, and not just network latency. I'm just thinking about overall application latency. You click on a data set and you want something on your screen and have it, of course, refined to more detail rapidly rather than waiting for an entire data set to download.
I think that was a really great overview and introduction to streamable data and especially geospatial data. Would you mind talking about some of the file formats or the streamable formats which make sense to use when we think about streaming our data from a server to a client? If you could just walk us through some of those things and perhaps how we get our data in those formats, that would be really interesting.
That's a very important question as well. So the concept of streamable data is one thing, but you need to have some agreement on how to get it from service to clients. What we typically rely on or aim for are OGC protocols, so the Open Geospatial Consortium protocols, because they are standardized by this consortium. And that means that you can interoperate between any client and any server. That's very important for us because we like to combine dataset from various sources. So if we would need proprietary protocols to get that data, then it's difficult to connect to, for example, a government server to get certain information. So these OGC protocols aim to interoperability. And I think there are a couple of well-known ones that have been around for years or decades even, like WMS, which is for serving imagery. And you might think that it's not suitable for streamable data, but actually if your server is a bit smart and your client as well, you can use that to load information in a tiled manner. The same goes for WCS, for example, for weather data or other multi-valued or even multispectral imagery. But of course, a dedicated protocol for tiled data like WMTS would be much better suited for this kind of data. If you're thinking about more modern data sets where you have 3D information, point clouds and meshes specifically, then the go-to protocol would be OGC 3D tiles. It's been made specifically for this use case. So it actually describes a metadata structure, a structure of your tile tree in a very fairly simple JSON format that you can download that does not contain data, but it contains links to the actual payload or data. So you can download this JSON body, inspect it, determine what data you're interested in based on your point of view, and then download specific chunks that I talked about earlier, tiles, if you wish, payloads to get the 3D information and put it on your screen. Apart from these, there are typically proprietary protocols as well, open source protocols, vendor-specific protocols. We have some of our own for things that are not yet specified by OGC or other bodies. For example, for geospatial video, for panoramic 360 images is very common these days as well, or for dynamic data such as positions of people or equipment. You asked about how do you get your data in such a format or such a protocol, because what we talked about is protocols, not actual data storage itself. And that's a very good question, because a lot of the data that we get is not at all suitable for this kind of streaming. I mentioned the raster image that is huge, and a very common thing is unstructured point cloud data. Point cloud sensors, they dump information as they scan it, and then that's just a very long list of more or less unstructured points. So you need to do some kind of massaging, processing on that data to get it into a streamable form. Other sources are very well suited for streaming. Sometimes we get data out of a database and we serve it on the fly rather than processing it up front. Or we do something intermediate where we process certain top-level tiles up front because these are commonly requested, but we do the more detailed tiles on the fly because we don't have to pre-process them all at once. So that these are hybrids that we use as well. To do that, you need tools. There are open source tools for certain use cases. In our case, we have our tools within the Luciad Fusion product that we can use to tile various kinds of data, raster data, elevation, multi-valued, LiDAR, meshes, etc. And it's actually quite an interesting challenge, I think. I think it's very interesting to work on because you have to find the right balance between tile sizes, tile count, so that you can tune it so that the client can have the right balance between downloading data, not too much, not too little, too fine grained, not too coarse, etc. This is very, very interesting challenge, I think, personally.
Yeah, and I think that that's a challenge a lot of us face when we think about what's the most efficient way of delivering our data to the client. It needs to be streamable. How do we tile it? What does that mean when we try and use that data later on as well? At least in my mind, when we tile data, we're kind of clumping it together, right? So we're making decisions about. It's almost like we're resampling it, and when we resample it, we lose a bit of detail, maybe a little bit of accuracy. Is that the way you look at this as well? Making decisions about the resolution that we're going to show to the client and therefore the accuracy of the data that we're going to make available?
Yes, there's certainly some algorithms and decisions, if you wish, involved in making these lower levels of detail. And what we typically do is we look at simplification algorithms that we can have tight control over so that we know the error that we introduce. And the error that we introduce should be such that it is not visible at the scale at which that level of detail is intended. To take a simple example of raster data, if you have a raster data of 100,000 by 100,000 pixels and you put it on your screen, that doesn't give you more information than a data set of 10,000 by 10,000 pixels because you don't have that many pixels on your screen anyway. So it's safe to reduce the amount of pixels. And the same goes for LiDAR data and for 3D mesh data. It's a bit more complex, especially for 3D meshes, because you have, on one hand, the triangles that the mesh is made of, and on the other hand, the textures that are applied on top of that. So you can kind of simplify both of them in conjunction, of course. So there's a lot of play between the two, and you have to decide. Yeah, you have to have an algorithm that keeps the quality under control. At the same time, though, when you zoom into the data at the point where you get very, very close to the data, we tend to keep the original data as much as possible so that you can get the original geometry if you need it for analysis or for some exporting or for some other reasons. It depends on the data source, I would say. In some cases, it doesn't even makes sense, the original geometry. For example, if you're talking about BIM data, the source of BIM data, it's a CAD object. Take a cylinder, so it's a mathematical cylinder with holes in it or whatnot, or curves, etc. So there's this mathematical representation of what it is. But in order to display it, you need to convert it into geometry that is understood by a GPU, by a graphics card. And the GPU doesn't speak cylinders, it speaks triangles. So you need to convert that anyway for display. And again, there you have a lot of options on how coarse grained or fine grained you need to make that cylinder in order to make it look as an actual tube rather than, let's say, a faceted surface.
I'm really pleased that you brought that up with displaying data on, on the graphics card or processing on the GPU, because that's probably what's going to be happening to it once we get it into the web client. Just because a data source is streamable, can we assume that it's in a format that's going to be easy to process on the graphics card when we get it over to a client? Or do we also need to think about that side of it as well when we're choosing a format?
For sure, these go hand in hand, and a format like OGC 3 Tiles has thought about that. And the payload, like the actual geometry data that is containing the data, is in a format called GLTF, which is a format that is very well suited to get your data on the GPU, because you want to have as little work as possible on the client to get it on the GPU, because every work that you do introduces visual latency and just CPU cycles on the client that can be avoided at best. So if you prepare your data, you want to prepare it in such a way that it aligns with how a GPU works. And for example, for a 3D mesh, that is typically a vertex array containing triangles with a texture next to it that can be applied on top of it. And if you embed that or encode that in a binary format that is easily decodable, like GLTF, then you can basically copy and paste your blob, your binary data from the file that you downloaded straight into the GPU. You don't need to process or parse any additional JSON to get the individual coordinates out of that, or maybe do some other decoding on top of that. And that makes it very efficient because you download the file, you get some high-level blobs out of that and put it on the GPU. So that makes it very efficient on the client. That goes hand in hand, yeah.
So I can definitely see this when we're talking about continuous data, but what about discrete data? Let's say I had a building layer with all the building footprints, as discrete polygons. What decisions would I actually have to make in terms of how I was going to stream it without losing too much accuracy once I actually got to the client? And how would I break up that data either on the server or on the client to make it work with a GPU, to make it into a parallel problem?
Well, I would advise you to use a tool that does that for you, because if you have to go about doing that yourself, you'll be spending a lot of time and effort to understand what makes a good level of detail structure. So I would definitely recommend you to find a tool that does that for you. What you mentioned, though, is very interesting as well, because there's all kinds of data sources for that eventually end up in the browser as streamable data. And not all of these are treated in the same way. I mentioned rasters already because it's a very, very common, goes back decades, data structure, and it's fairly straightforward to chop that up into tiles. Because I think that's something you can easily imagine. You have your piece of paper, let's say, you just take a scissors and cut tiles out of it. And so that's easy to imagine. But the case you described, like building footprints where you have polygons, and I guess that's what you meant is GIS polygons and maybe points and polylines, then a polygon itself, the definition itself, is not suitable for a graphics card because, as I mentioned, it speaks triangles. So you need some tools to convert it into triangles, and maybe then before or after converting them to triangles, chop them up into parts. And that's definitely a non-trivial task, especially if you really want to support data sources from various sources. Then you can have them in different georeferences and things like that. If you take that all into account, it's definitely a tricky problem. Other data sources are LiDAR data. And there it's again different because the LiDAR data is unstructured in the sense that you can have dense data in a certain area, coarse data in another area. For example, you have a sensor and you scan the same thing twice and there's some overlap that will have more dense data than other areas. Or things that you scanned in the distance, obviously the points are further apart than things that you scan nearby. as you can imagine, because the LiDAR sensor, it samples discrete locations at a certain angular accuracy, let's say. So that's something you have to take into account when you process LiDAR data as well, that you reduce the amount of points or keep the amount of points so that it's roughly consistent over your data set. And city meshes, as mentioned, or meshes in general, there's even more different data sources that end up as meshes. I mentioned BIM data, which originates from a database storing CAD objects in mathematical, geometrical form, or from files. It can be an IFC file or a Revit file. It's actually a good example because an IFC file, they tend to get really big, and you kind of load them in a CAD tool and then export them to IFC, and it takes 2 hours to export them to IFC or to load it back in. So that's obviously, it's an exchange format and it contains all of the information, but it's definitely not suited for streaming. So you need some processing on that. Other sources of mesh data that are somewhat related to BIM is CityGML or CityDB, where you have building information in various levels of detail in either a file or a database. But again, you need, if it's in a database, you could do that on the fly, but if it's in a file, it gets too big, then you need to do something on that. And very different mesh data is reconstructed mesh data from a reality capture. If you do an aerial scan, you can reconstruct that aerial scan into a triangle mesh with a texture on top of that. And that's very different data from BIM data that contains object modeling.
I think you've given us an amazing overview and a very detailed walkthrough of what streamable data is, what it looks like in terms of geospatial data, some of the things we need to start thinking about if we're going to make our data streamable, the different formats we can use, and a few sort of more detailed use cases in there. Thank you very much for that. And the idea, of course, with streamable data is to make it available to a client. And again, you've talked about why we want to do this and that when it comes onto the client, it needs to be available to be consumed in parallel on the GPU. Would you mind now sort of walking us through what we can do in the client once we have the streamable data, once we have it available to the GPU? What can we actually do with it in a web client?
So a web client in the general sense is not much different from a desktop client in the sense that you have the WebGL API that gives you access to the GPU. WebGL itself is very close to OpenGL. So if you're known with OpenGL and you know the programming paradigm, you can apply that with a JavaScript or TypeScript source in the same way, and even with the same GLSL shader language. So it unlocks your GPU. That's a programming API. But what can you do with that is it allows you two things: visualize your data fluently, which is in itself, I think, very important, because if your interaction and display is not fluent and you have to wait for it, even though it might not be a long time to wait for it, it kind of reduces your user experience a lot. So making it look fluent, making it look nice, and by nice I mean applying lighting effects or other visual effects that enhance the visual quality of your data, is something that you can do with a GPU very well, because obviously it's been used for that in the gaming industry a lot. But the GPU is also very useful for implementing certain kinds of functionality on your data. So visualizing is one thing, but getting information out of your data using functionality is very powerful as well. And if you can do that with a GPU in an interactive manner, that really enhances user experience. Just to give you a couple of ideas of what functionality you could build on that in a sort of abstract terms is styling, instant restyling. For example, highlighting certain parts of your data in different colors, or filtering, hiding certain kinds of parts of your data that are not relevant to the investigation that you're doing. It can be anything, but it's a very common thing that you want to reduce the amount of things on your screen so that you can focus your attention on the parts that are relevant to your task. And styling goes with that, of course. If you can then highlight certain items and attract attention to that, either by configuring things on the client or guided by some sort of algorithm, maybe an AI or machine learning algorithm on the backend that gives you information that you can then apply as styling to attract the user's attention. And if that goes like in a blink of an eye, that makes it very easy to try out different things, to play with settings and not configure something, click on a button, and then go have coffee, or in the worst case, maybe have to wait overnight to get to get back information to find out that it's not what you were looking for.
So when I see these kind of applications, I'm completely fascinated by the ones where you can walk through them, right? So we have this 3D data and we can walk through the scene or move through the scene. And the reason why this fascinates me is because it's, at least for me, this is the magic of Google Maps when it first came out. It puts the user at the center of the map, at the center of the experience, and is visually filtering the map by what they can see. So instead of overwhelming them with detail, it's making the scene more relevant to the user as they move through it. Is this one of the things that is enabled by this GPU processing in the browser? Is that like without that, could we have a similar experience?
You could do things without a GPU as well, but I think it goes hand in hand because you get the raw visualization power of the GPU, and if you can apply certain rules, styling, filtering, whatever on the GPU, then they are in effect immediately. So that's certainly very powerful. That doesn't mean that it's the only way to do it, and in fact, it usually isn't, because you usually get additional information from a backend in order to guide that process on the client. Like we said earlier, in an application that uses streamable data, you don't have all of the data available. So if you want to attract the user's attention to something that hasn't been loaded on the client, then of course you'll need additional information from the server to maybe allow the users to navigate to an area that is of interest. Because if you're looking at an entire city and you're, for example, investigating trees that have grown too large, then you're not going through each and every tree hand by hand. You want to be guided by information and then inspect manually, visually, parts that are highly likely to be relevant. That's just to give you an example.
So one of the things that I see people doing on web maps all the time is this, that they click on an object, right? So show me stuff about this object. Do we lose some of that when we start to talk about streamable data? Do we lose access to those attributes when we start to tile up our data into different sort of geographic areas, perhaps, and send them to the clients? Or is this still possible?
Well, if you do it right, you can. Yes, it's definitely very important for us because we'd like to get analysis and insight from the data. And if you lose information along the road, then yeah, it limits your ability to get information out of that. So we like to retain information, or at least backlinks to the original data, so that we can get this information. Sometimes often even it doesn't make sense to retain all of the source information in the 3D tiles or in the streamable format, but only some sort of ID or backlink so that you can go back to your original data and get the full information out of that. It depends a bit on the use case, but it's very important, yeah, because then you can click on an object and either have the information at hand, or using this ID, get all of the information you need, maybe for multiple systems even, because often, especially in BIM CAD world, an object is not one object, but it refers to many other objects. And you might need to download or get let's say, a part of this graph to your client, because you need to know the relationships between a structural element and things around it. That's certainly very important, yeah. And the same applies, for example, so this was an example in BIM, but if you take an example in a city mesh, if you have, based on aerial imagery, for example, if you have classification information, which often is available, then you can keep that classification information in the visual mesh and use it to guide the visualization, or at least to click on it and know what the algorithm decided to do with that, or maybe link that back to a certain BIM object. So if you have a city mesh and has the same building but in a reality capture way, and you can link that back to a BIM model, that's very powerful as well.
If we go back to that building footprint example that we used before, could you give me an idea of the kinds of things that I could calculate in the client, and the kinds of things in terms of attributes of geometries or attributes that are attached to that building footprint in the original data? So the kinds of things I can calculate in the client and the kinds of things I would need to retrieve from the server?
So if you're talking about building footprint, I suppose you mean like a CAD model or a BIM model of that building, or are you referring to, let's say, a blueprint, 2D blueprint?
I'm just thinking about a discrete object, so polygons, that kind of thing, that represent a building footprint. I'm not too fussed about what format they're in, but just that idea that this is a discrete object here, it's not continuous, and it has certain attributes attached to it. And then I'm wondering, so when I turn that into something that's streamable, take it over into the client, what attributes can I calculate in the client based on that geometry that I have available to me, and what attributes would I be wanting to link back to on the server?
I think, as I mentioned, it depends a bit on the use case. If you foresee that your application will continuously need certain kinds of information, then you make sure that that information is readily available in the streamable data. If that is an exception, then I would go for a backlink and make sure that you can download this information when you need it. And then in either case, regardless of whether you embed the information upfront or you embed only a link, you can retain all of the information of the source object. In the case where I mentioned, if you represent a structural element as a pipe, then you can get the original geometry of that pipe, or probably more importantly, the properties like what material is it, what strength does it represent, what's the radius, does it intersect with other objects, things like that. There are things you can definitely do on the client, potentially guided by a server.
I realize we're jumping back in the conversation about streamable data a little bit now, but how easy is it to update something like a 3D mesh, for example? Let's say I go back to my building footprints. I've decided to represent them as a mesh, stream them into the client. Oh, I need to be able to calculate a certain attribute or retrieve a certain attribute. How easy is it to update that mesh?
That's a good question, because it's not necessarily obvious, because when you're making a data available as a streamable data set, depends a bit on how you approach it, whether it's a copy or not. And I mentioned earlier that we, depending on the source data, can do certain things on the fly or completely processed or a hybrid in between. But in either case, you can do updates on your data on the source data. And that's typically what you want, because if you want to change the properties of a certain element and the source data is in a database or somewhere, then you want to push that update into the database and then invalidate your streamable data. And since you know very well what tiles in your streamable data will be affected, you don't have to redo everything. You can validate parts of the streamable data that is affected. How fast that is being applied depends a bit on your use case. Sometimes it's not necessary to have that being applied instantly, and it can be done asynchronously, maybe in a batch job or something like that. Sometimes it is important. In that case, there are strategies as well to get updated data on top of your base data, or replacing your original base data.
So it sounds like a lot of this depends on the tiling format we've decided to go with, whether we're tiling on the fly, whether we've seeded a particular area, perhaps we've made a global tile set. So we have a change coming into our database, and then we need to look at so what tile sets are affected by this and then update those tile sets. Am I on the right track?
Yeah, exactly. Yeah, that's how we would approach it.
So I think the next piece of this conversation I'd really like to sort of focus on is use cases. So we've talked about the streamable data, we've talked about what we can do with it once it's into the client, how we might update things, how that client server relationship, what it might look like, perhaps even how it might change over time in terms of where we do our calculations, where we make the decisions to calculate things, whether it's on the fly, in the client, or on the back end. Would you mind talking to us about some use cases for this? Like, have you got anything in particular that you would like to sort of draw our attention to?
There are many use cases. Maybe one that we could talk about is emergency response. That's, I think, a very interesting one, because it's something that has been growing over the years. It's not that far yet, but I think it's really on the forefront of breaking through. Emergency response, I mean things like handling events. It doesn't have to be scary events. It could be like forest fires, which are really scary, but it could also be like maybe managing protests or something like that, where you need to monitor the situation. And there you want to make sure that you can combine data sets on the fly that you don't even anticipate on in your application. You work with the data that is available. Hopefully there's a lot of data available, get it from various different sources and combine it on the client. And if you can do that rapidly without having to download huge amounts of data, or maybe can use tools to convert from one to the other because your application doesn't do it, that's a huge advantage, because it reduces your latency to get information. Your workflow is in time compressed. That allows you to respond faster to certain events. And in such a use case, you typically have a lot of different possible data sources. You have, say, more traditional GIS data sources like street network, or an aerial imagery, or Maybe if it's about fire, you could have like the water infrastructure in the area, like fire hydrants that you can hook up to, things like that. These are traditional GIS information, but you combine that with more modern information, such as maybe a drone flying around. It's capturing a video feed live, and you want to get that on top of your GIS information so that you can react to it and find, for example, a spot to hook up your water pipe to a fire hydrant that is both close to the fire but not too close, something like that. I'm just making things up. I'm definitely not familiar with this use case, but it could be like, if in this case it could be like you need a building information BIM model of a place where there is a fire, for example, or where there is an event. If you have that BIM information and you can, for example, slice through it and hide certain levels of certain floors of your data, so that you know you can decide how to navigate indoor, or which entry to take if you're outside, and you can decide where to park your fire truck and which entry to take, or something like that. That's really powerful if you can do that in the blink of an eye. That's I think the important part. If you have to do that and wait for even just 1 hour or something like that, that could already be too late. If you can do that on rapidly in a couple of clicks, that really makes a difference in this case.
Yeah, I think that's a really interesting example because of all the different data sources that would be used and necessary, and lots of different data formats in there as well. But also in terms of the user. So it sounds like a dashboard kind of thing to me, and so I'm thinking that there's perhaps not a geospatial specialist on the other side of that dashboard.
For sure, yeah. Then you get into the more user experience and user interface domain, is how you make such applications where you cannot really foresee all of the use cases, but you still want to keep it entry level, or manageable by people that just want to get productive from the very get go. They don't want to do a training. That's a usability question. It's definitely not easy, because one thing that we noticed when going from 2D oriented applications to 3D is that working with 3D data is sometimes less intuitive than working with 2D data. Your camera in 2D is constrained. You're looking from the top essentially on your data. So you have navigation in 2 degrees of freedom, but in 3D there's a lot more factors. You can not just navigate in 3D, but you can rotate and tilt your camera in various ways. And if you don't manage that in your application, if you don't restrain in a certain way what the user can do, then they'll get lost in the data, and they'll have trouble finding the right angles to look at the data. So you really have to help the user there, and sometimes even constrain the user so that they don't get lost.
I think that's a really interesting insight because I think a lot of us that are building these applications online, we're used to thinking about constraining the user or making decisions for the user in terms of who can see this. This would be a classic one, right? Who has access to use this application? And then what tools, what functionality are available, what data is available. But what you're talking about is the interaction, like how they can visually interact with the data and move through it. And that's something I hadn't personally thought of before.
Yeah, yeah. I think it's something we see a lot. If you build something with the not just with our tools, but with 3D tools, and you use the low level toolkits available to manipulate the camera, then you basically have to be an expert user to understand how to navigate and what your mouse clicks and things do to get to a certain usable vantage point. That's certainly something that we have built an abstraction on top of that to allow people to build an application that guides the user and makes it easy to interact with the data. And by extension, that doesn't apply to just looking at the data, but it also applies to a lot of things. For example, like the things that I mentioned, filtering and reducing the amount of data. If you have the tools available in your application to do that easily, you can help the user with that. Of course, it goes into the application domain as well. To come back to the example that we mentioned about emergency response, if you're managing an emergency in a certain part of town, you want to be looking for data sets that are relevant. And so you want to be presented with options that are relevant. That's, of course, a very domain specific thing to a certain degree. But on the other hand, it's also managing geospatial data. It's more of a backend thing, probably, where you want to query various backends for information and pass along the right query so that you get information that is relevant. And And location is of course a very, very important aspect of such a query, but it could be other queries as well. Like I need to go back in time, probably not for an emergency use case, but for city planning use cases or for other use cases, you want to go back in time and compare. So then you want to adjust your query accordingly.
So we've come a long way in our journey now. We started talking about streamable data and what we needed to do to make data streamable, why it needed to be streamable, and what we could do with it once it was streamable on the client. And I completely understand a lot of the arguments for doing this in a web browser on a web client. When is a web browser not the right answer for visualizing and for analyzing geospatial data?
Yeah, that's very relevant. It's certainly not always the right choice, and I think you can see the distinction if you look at the applications that are currently being deployed as desktop applications versus web apps. If you need the full power of your PC to work on a rather dedicated use case, then a desktop application is a very good choice because you get the full CPU power, all of your RAM that is available, get disk access, typically on fast disk access, and you get your full GPU. In a web browser, it unlocks all of that for sure, and especially over the last couple of years, you get more and more of these capabilities available in a web app, but it doesn't give you the full power of your PC. So that's definitely one thing. And when is that relevant? And it's typically when you're doing specific use cases over and over, and you're, for example, if you're a BIM modeler and that's your thing and you're working on a specific building for a long time, which I guess is usually the case, then it does make sense to have the entire BIM model available, loaded in your application, because that's what you're working with. Whereas if you have a use case where you don't necessarily know upfront what you're going to do, or even what area or what kind of data you will need, then a web application is very useful and powerful because you can get the data on the fly without having to prepare your use case too much. I think that's a very important distinction. And you can see that if you look at, for example, CAD programs, they're typically desktop applications because the people that are using them, it's not just because it's traditionally, historically a web desktop application. That's, I'm sure, one part of the deal. But the other part is that people that are using these applications are using them 8 hours a day, every day on a small set of data. It could be big data still, it typically is, but it is the same data in a relatively long period of time. Whereas if you really go to different kinds of data, combining multiple kinds of data that you don't even know up front, then I think a web app is really powerful. And maybe what I touched upon at the start, I think a bit, is that it's not just about the data, but it's also about the functionality. Desktop application is typically well suited for power users that are doing deep into certain tasks. Whereas with a web application, you can tailor your web application, and typically that's fairly easy to, let's say, adjust your web application to certain use cases that are more entry level in a way, or that are more disparate. So you could have different users having different use cases, but working on the same data. And you could easily tailor your applications for these use cases.
Do you see, when you look out into the future now, do you see the web environment and the desktop environment coming closer and closer together? We see more and more apps on the web that are functioning in a web browser. Is there anything out there at the moment when you think about the trends in the industry, the trends in technology, where you can see these two things converging sometime in the future? And I guess what I see is I see people storing their data. Data is getting bigger and bigger, and there's this move towards storing it on the cloud, storing it somewhere where it's accessible to a lot of other people and easily shareable and in one place, as opposed to making multiple copies of it all over the place. Lots of desktop applications are actually streaming data into them, and that you're working on the data in a desktop application, but it's being streamed into. And in that sense, it's working a little bit like a web client. So I realize this was a long question, but again, can you see these two things converging in the future, where to the point where perhaps it's hard to tell the difference between a desktop and a web client?
Web applications are taking over more and more possibilities of a desktop application. Let's say 5, 6, 7 years back, talking about accessing your GPU on a web application would be a state of the art, cutting edge. Nowadays, if you're talking about AR and VR in a web application, that is possible. It's still cutting edge, but it's possible. So that's something that the web domain takes up more and more of the use cases of desktop applications where you would access local hardware maybe peripherals like, yeah, of course, a webcam is something you can already for a long time do in a web application, but that extends the domain of a web application on your client extends into things that traditionally were only even technically possible with a desktop application. That's one area where the browser applications eat up, let's say, use cases from the desktop applications. And if you combine that with all of the, like you rightly mentioned, all of the software as a service and cloud service and cloud storage benefits, that's really a very powerful combination that I only see getting stronger and stronger.
Joris, thank you so much for spending time with me, for patiently walking me through this. It's complicated, at least for someone like me. So I really appreciate your expertise, and I appreciate some of the explanations you've shared with us today. Thank you so much. Is there somewhere we can go if we want to reach out to you personally, or if we want to connect with some of the work that you're doing?
So, first of all, thanks for having me. It was a really nice conversation. I hope the listeners learned something. Yeah, you can definitely go to the Hexagon Geospatial website. If you look it on Google, you'll find it, and there you'll find all of the information on the SDKs that we Luciad make.
Thanks again. I really appreciate your time.
You're welcome.
So I really hope you enjoyed that episode with Joris. I hope that you learned something about streamable data and what we can do to get our data in a streamable format, what formats or protocols we should be thinking about, the decisions we need to make along the way, and perhaps what that means once we get data from the server to the client. I apologize for butchering Joris's name repeatedly throughout this episode. To make it easier for you to find him and catch up with him and learn more about what he's doing, check out the links in the show notes. And that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. I really appreciate your time. I realize there's a bunch of other options out there, and the fact that you chose to listen to this one really, really means a lot to me. So thank you so much for that. As always, you can reach out to me on social media. I'm most active on Twitter and LinkedIn. There'll be links to those profiles in the show notes if you'd like to get in touch. Otherwise, you're more than welcome to contact me on email, just info@mapscaping.com. It would be fantastic to hear from you. Okay, that's it from me. We'll talk again next week. Bye.